This is the wind sensor that we are using on the top of the mast at the moment on Woodstock, and we took a commercial design that Dick bought and ripped out the electronics and replaced them with a Hall effect angle sensor. But the thing was not intended to be waterproof, and it isn't waterproof at all. Just keeping a watch on what other sensors are available. This CM2-WD is a wind direction sensor for a commercially available weather station, and very modestly priced. So I bought one of these just to see how it would work. I've been looking at this commercially available wind vane just in case we can use the housing. When I first saw this, it's got this cable with an I think it's called an RJ22 connector, the kind of connector you have on the end of your phone, or actually plugging into your phone. I think it's called a 4P4C connector. Well, that's all right, but then I looked in here and I thought, well, this looks like a network interface there. I hope the electronics isn't too complicated. However, that is also an RJ22 socket. I'm not quite sure what it's for. Anyway, I took this apart. It has, this is just a mounting, and then inside it there is this, which is basically 8 reed switches and a few resistors. There's no active components at all in here. I worked out the circuit. It basically just consists of 8 switches, 8 resistors in parallel. And the really odd thing about it is that this socket is not connected to anything on this board. So I haven't a clue what that's for. So here we have a plastic case which has no holes going upwards in it. And I took this top off. Basically, what you've got is a sealed ball bearing there, which is fitted onto this plastic stub axle, and I think that they've just melted the top to stop it coming off. And then that bearing is press fitted into this. And there's a little magnet here. There's no water passage from the top here to the inside, which is nice. The odd thing about this moulding is I don't really understand what these two sort of cylindrical holes are for. And the other odd thing is that, as you can see, probably I hope, that the magnet is actually right on the periphery here, so that it's actually going around the outside of these reed switches. Had I designed it, I'd have put the magnet about there so that it went over the top of the reed switches. Don't quite understand why they've done that. Perhaps that's an alternative. Perhaps those things are an alternative, but they're not the same height. I was thinking maybe they're an alternative mounting for a magnet. So what I've got here is a 10 volt power supply connected through the wind vane in series with a 1k resistor and back to the power supply, and I'm just measuring the voltage across the 1k resistor. So as the resistance in this changes, the voltage across this resistor changes. And if I just so here we've got 2.5 rotations on the screen. If we just look at the middle one, we've got 1, 2, 3, 4, 5, 6, 7, 8 possible readings, and then it repeats. These areas here this one, that one and that one are situations where none of the reed switches are on. They're all off, and therefore we've got a reading of 0 volts. This one is particularly worrying because it suggests that you could get a reading of 0 volts for quite for a significant angle between these two valid readings. These spikes here are due to 2 reed switches being on at once, putting 2 resistors in parallel and thus giving a higher voltage, or lower resistance, higher voltage. So this thing has to be interpreted carefully if you wanted to get accurate readings from it. Of course, on a real boat, when the mast is waving around, the wind vane would never stop at a point like this and give you a 0 reading for long. So what would actually happen is you get a reading, this reading or that reading, in between these readings, these values of 0. So one could simply ignore the 0 readings and average the angle between the other voltages that you get. This device does swing very easily on its single ball bearing, but it's not as robust as Ollie's design. You can see that there's some rock in it there, and likewise that direction, which is simply caused by the fact that the bearing is not very rigidly mounted on that plastic spigot. So I think not as robust as Ollie's design, but one could have an arrangement like this in which there was 2 magnets closer to the centre acting as a magnetic clutch, and another 2 underneath in the waterproof part, being driven by the magnets on top. And that would provide another way of doing things. So it's useful to know that this exists, but I shall press on with the other design that we have underway.